Thank you all for coming. This is the traffic analysis panel, and I apologize a bit for not having a lot of details in the program, but thanks for coming anyway. The speakers that we have here, I'm very fortunate to have a really good group. That end we have Raven Alder, who's hacker extraordinaire, capable of doing nearly everything. On the other end I have Ricardo Batati, who is professor at Texas A&M University and has also done a lot of work on this field, so he has some great slides to show. I'm John Callis. I am CTO at PGP Corporation. I have been doing security and cryptography for entirely too long. We also have Nick Mathewson, who is one of the developers of Tor. So between the four of us, I think that we have a really, really good group covering a broad spectrum of experience and ability to talk about what really is the most difficult problem that we face in security today. So what is traffic analysis? Very simply, traffic analysis is signals intelligence that ignores the content. It is looking at the problem of figuring out what your opponent is doing and saying, screw it, I'm not even going to bother to try to read it. I'm just going to look at patterns in various dimensions and then see what goes on. You can consider it to be metadata analysis and metadata only analysis. It looks at all sorts of things like who's talking to whom, how long they're talking, where are they, who do they call after that, so on and so forth. And then you start constructing models of what you know about the opponent based upon the metadata only. It also extends to some very interesting things like analyzing social networks. Now, it's really, really important because it's extraordinarily easy to do. Traffic analysis is looking at things that are hard to hide. All the time there is more data available. The more that we use wired devices, the more we use wireless devices, the more that we are doing signaling, the more that there is for somebody who's doing traffic analysis to get a base of data to start constructing things out of. Also, it's extraordinarily hard to protect against. Any of the defenses that you do are frequently extraordinarily expensive. There are ways to break the defenses themselves, or they really aren't very pleasant for you to do. I mean, for example, you could get rid of your cell phone, you could get rid of your wireless card, you could stop using the internet, but what fun would that be? So, let me give you a scenario. Let's just suppose that you have a worldwide data collection system. I mean, it could happen. I mean, somebody might have one. Let's also suppose that there's ubiquitous crypto and that it's pretty good crypto. So the major problem that you're going to have is that you're going to have data reduction problems because you have this worldwide network and there's all sorts of things going on and a lot of it's being encrypted. So you need to, in many cases, throw stuff out and figure out what it is that you need to throw out, and that is in fact one of your biggest problems. So how would you solve the problem with your worldwide collection network of coming up with as much information as you could? And the obvious answer is traffic analysis. So why are we having this panel? I have been personally concerned about traffic analysis for a long, long time. That as PGP architect and developer, I have known that anytime you send an encrypted message using PGP or anything else out on the wire, it basically screams, hello, I'm an encrypted message. So actually sucking up the encrypted messages is the easiest thing there is. I mean, this is an irony, is that cryptography is not a help here. There is increasing evidence that what they, and by they I mean intelligence organizations, marketing people, the mob, and so on, that they are doing traffic analysis for many of the reasons that I described before. And I think that it is, in fact, the key threat to privacy. So I also think that we need to shift our mindsets about the way that we look at this. There's a tendency to look at things like the NSA wiretapping scandal and say, oh, they're listening to our phone calls. And in fact, they're not. I've been paying close attention to it, and that was my inspiration for this, is that the more I looked at this, the more I said, ooh, they're doing traffic analysis. And I mentioned this to Jeff Moss and said that we really ought to start talking about it, because that seems to be the shift of where things are going to, and it may very well be that the answer to why over the last 6 or 7 years has there only been an increase in liberalization of restrictions on cryptography is that the intelligence organizations have decided, screw it, we don't care anymore. We're going to shift our tactics away from the old school and into the new school. And that means that we need to shift the way that we think about this. But also, every technology can be used for good or ill. I mean, you can take a hammer and you can drive a nail, you can smash in somebody's head. So, if you know, the idea that technology itself might somehow be particularly evil might apply to certain things like, oh, you know, nuclear weapons and chemical weapons, but when you get to things like fire, you would have to give that up. So it's best to look at these things. So the way I'm going to structure this is that we want to have a conversation about traffic analysis. Ricardo has some slides that he's going to show after I'm done here in a moment that describe a little bit of what's going on in the world of traffic analysis, and then we're all going to talk about things. We're welcome to have questions, but we really only have 50 minutes here, and this is a topic that we could talk about for days. So we've been talking over the last week or so. If you got a question, ask it, but if I cut you off, please don't take it personally. Now, lastly, here's a really good source. This is by George Donesis. He's got a paper that he wrote late last year, an introduction to traffic analysis, and also his slides for the talk that he gave. Read them on the way home. If you're on the net now, download them now, but read them later. It is a really good introduction of exactly what's going on, some historical context, and so on and so forth. So that's it for me. And let me get the next set of slides here.
Hello, my name is Ricardo Bettati. I'm from Texas A&M University. The background of our group is originally a long time ago in real-time systems. So time for us is an important topic. And so we are looking at traffic analysis from a timing analysis point of view. So we kind of look at the underlying SIGINT mechanisms that then support traffic analysis on top of it. So I would like to show maybe a few hopefully reasonably scary scenarios and capabilities that we have today with timing analysis, and what can go wrong if you try to design countermeasures. Now, this is a well-known result that says if you listen to an SSH conversation, you basically can break it with no sweat, right? You basically hear the typing, and that's a long story. So that's one well-known timing attack. So if you hear a 250 millisecond inter-packet time on an SSH channel, that gives you roughly 2 bits of information, right? That's without any a priori knowledge about what is typed. So if you knew that what is typed is English, then you have a lot of a priori information, and you break the conversation with no sweat at all. Here, this is the result of a term paper that I had a student write, where we basically listen to a machine that is sending data, and we are just doing some, a bunch of possible configurations of machines, different configurations of network interface cards and operating systems, and we run a bunch of classifiers on them, and it's absolutely easy to, this is basically an afternoon worth of work. It's absolutely easy to figure out what is the operating system hardware configuration of that machine without looking at the packets that are sent. We just count packets over intervals. Another application that we have kind of looked at recently was bot detection, right? Everybody would like to know if the participants on the poker table are real or bots. Here is an application where we look at honeybee, and and with very few packets we can figure out whether it's a honeypot or not. And this is without looking at the packets, without looking at the protocols. We treat the entire machine as a black box. It's just the timing. And the results are trivial. It's because the underlying timer is really poorly implemented, right? And we see this. So what are countermeasures? Link padding is a classical countermeasure. You have an underlying traffic pattern, and what you put is some sort of a cover pattern on top of it. And so this is a possible implementation thereof, and it shows that the problem is that link padding is really, really, really hard. And here, actually, it's very difficult to see. Maybe we can basically listen on the radio. The cover channel that goes over a linked a padded link for even a passive observer is a very high capacity channel. Other scenarios, and here we are looking at a naive implementation of an anonymous networking scheme. Some of those if we look at the naive implementation of a so-called mixed network, problem is those networks interfere with the delivery of TCP traffic. So if you start mucking around with TCP becomes very highly visible. And so it's very easy to identify flows and where they go to. Now again, this is just a naive implementation. If you make larger networks, you muck with TCP even more and it gets worse. Actually, the results are even worse. We don't need to do end-to-end analysis. What we basically can say is that even if we just measure aggregates in a network, we think about it, we just have a bunch of measurements that do nothing else than count packets. We don't look at the packets. We don't know where they come from. We don't see headers, nothing. We just count packets. And by counting packets, we can identify individual flows. All we have is access to aggregates. We can dissect the aggregates into individual flows without even knowing what those flows could be. This is a signal processing technique called blind source separation. Think of it as for people who are familiar with tomography, this is tomography on steroids, or tomography with no safety net. Even if we have crowds, we have access to only aggregate data, and we have no models of the traffic. All we do is we count packets. It's very easy to get end-to-end connectivity. It gets even worse. When we go in the wireless network, we can, even with simple sensors that can only count packets, they don't know where the packets come from, they have no MAC address, they have no payload information, no nothing. We can separate all the flows into individual flows. We can identify, because of reachability, we can identify where they come from with very high accuracy. That's physical geography. We can, so these are, we have sensors, to think of it as 802.11 receivers that we scattered in the field, and we just have a bunch of 802.11 senders that are not distinguishable in any way, and we can still locate them to a few meters. It's even worse. We can reconstruct the path. In this particular case, we know that the sender is in the middle of that white blob, and we know the possible locations where that sender is talking to, because the same signal, although it's again hidden in aggregates, can be separated out, and we can guess roughly where the receiver is. Now the receiver happens to be I'm not sure how well you can see this, but the receiver happens to be where the other blue star is, and we have an estimated region where that receiver is. Okay, this is just a little overview on some of the techniques that could be used to provide the underlying signal processing for traffic analysis.
Yeah, go ahead. Pardon? Again?
Yeah, go to my website, and there is a paper that has a good, extremely good reference. Yeah. Pardon?
We want to know URL.
Do a Google search. Here.
Google Betat, there is only one.
Yeah. I'll go back and get that. So I'm going to start off with discussion here, and we have Tor developer here. So Nick, what can be done? I mean, you know, we painted a very bleak picture here, but what we've also been talking about is worst cases. We really have been talking about what happens when you have a lot of large-scale surveillance, but there are very effective things that you can do in a lot of normal cases. So what is possible and useful?
Well, let's start. Actually, I think I'd like to start with a example. And is this mic on? Good. Can people hear me? Okay. Good. So I'm going to claim that we should start by resisting comparatively weaker attackers. Most of this, a lot of stuff that is going on in the literature right now is ways to try to, given certain amounts of data, do interesting things to larger systems or systems that try to take specific steps. But something that hasn't really reached public understanding, and I don't even think in the community here has gotten enough attention, is what you can do just by looking. Because most people are not taking active steps to resist traffic analysis. Running Tor helps, but you know, a lot of people aren't. And you know, and because of that, you know, you don't need to do any kind of analysis on data streams. You don't need to do any sort of timing analysis. You can simply look at the traffic on the network, and yes, it's encrypted, but you know where it's going. The size of data being transmitted is not obscured. You can combine for stuff that isn't encrypted, you can combine individual non-encrypted pieces of data to come up with an interesting profile of people. For instance, if I know, say, I can tell that you're SSHing into this machine here, which is also running the website of so-and-so, and no one else's website, so probably that's you. So now I know who you are. I see you visiting another website, downloading an SSL file of a certain size. Well, that website only downloading a file via SSL of a certain size. Well, that website only has a certain number of pages, and only a few pages actually follow that particular size distribution, so now I know what you did. That page is a form. Well, all right, there's only a few options. You sent something in that makes me think you sent in a dozen characters or so. That probably means you chose option such and such. And later on, you visit some LiveJournal friends page. Maybe that's you. Maybe that's an account you didn't want linked. You visit a bunch of other sites, and basically, I can get a pretty good profile of you from just observation right now if you aren't taking steps against it. So yes, back to the original question, what can be done? It kind of depends against whom. Against a large intelligence agency that is eavesdropping a whole lot and maybe might know somebody who knows statistics and can read papers, not a lot right now. Sorry, don't arouse suspicion, carry on conversations in person in quiet tones. But, you know, against the folks in this room, yeah, you can do pretty well, I think. Anybody want to add anything? Did I even answer the question?
Raven, do you want?
One of the other things that I've seen recently, and something that you guys can do, many sites, particularly social networking sites, it's sort of a peer model. You know, you can link to people, they can link to you, and there's differentiation between who does that, and that can be a really valuable source of information. You know, for those of you on LiveJournal, I'm sure you've seen people stomp off and delete their LiveJournal and have a tantrum, and then suddenly, like 2 days later, someone pops up with all the same friends, and you know, it's not really hard to figure out. There are options on some of these sites for obscuring who is allowed to see who your friends are, etc. But a lot of the time there's back-end databases that are publicly mineable that do this sort of thing as well. we were discussing in the prep dinner last night that we haven't seen a lot of cross-site correlation, but, you know, if I'm Raven at LiveJournal, I'm not, but, you know, maybe I'm also Raven at Orkut or Raven at LinkedIn or what have you, and you can look at those and see if there are similar data patterns across those as well. One of the things that I found, being privacy aware, I've tried for years to make sure that when you Google my name, what pops up is mostly respectable. You know, you see me posting to Linux Chicks, and you know, you get my own web page and a couple of articles that were written, and I was very pleased by that. So last year, there was a piece in Slashdot that was written about me, and that caused a million of my well-meaning, not-so-security-aware friends to write posts that were public in their blogs or other forums going, oh, hey, my friend Raven's in Slashdot, link to article that contains my full name. And, oh my God, I remember when we went to Lesbian Ninja Pirate Weekend and did blah, blah, blah. I'm like, ugh. You know, this is not what I need future employers to be Googling on. So, you know, the lesson there is that even if you are paranoid and careful, you may be linked to people who are not paranoid and careful. And just by looking at those patterns, you're still in trouble. So I went around and thwacked all my friends with the security bat for a couple of weeks and explained why it was I didn't want them doing this and had to wait for it to expire from the Google cache, but I'm sure archive.org's got it. So don't be me.
So I'll add in a little too, which is that there still are nonetheless tools that you can use, and Tor is a valuable one. You just have to understand what it's good for. I mean, for example, suppose that you don't want anybody to know that you got a copy of PGP. Well, if they're really after you, that might be kind of difficult, particularly if you start sending a lot of emails using it, because they will say begin PGP message at the beginning of them all. But downloading the software from Tor doesn't put you in our weblogs. Similarly, anything else where you go, I mean, Tor has this ability to remove or blunt some of the signals that people are going to get from log analysis. And particularly because logs are very likely to be retained for God only knows how long. Relatively few people have policies about how quickly they burn them. So if you're going to be there and you don't want anybody to know what IP address that you downloaded something from, it's very simple. I mean, use Tor. Tor will protect you from that level of analysis where there's lots of stuff that's been lying around in tracks that can be done from IP address and geolocation after the fact.
It will also be helpful for you guys to just think about the metadata that you're sort of scattering in your wake as you go around living your daily lives. You know, I think probably half of you have cell phones that are probably turned on, and that will give, you know, hey, this phone is registered to the network in, you know, roughly this area with respect to a tower at this time. And if you don't want people to know you're hanging out at DEFCON, that might not be the most brilliant thing to do. Every time you use your credit card or something like that, you leave a little bit of data footprinting. And even if you don't look at, okay, how much you spent or where you spent it, you can still see, okay, the credit card was in use at this time, and that provides tracking information about you that you want to be aware of. So just start thinking about these things. I'm sure most of you have already had some thoughts along those lines.
So the next thing is I want to get a little bit more theoretic just for a bit, and that's to talk about what we as a group can start doing with this, because traffic analysis properly applied is an extraordinarily powerful tool. And we could start using it for doing things like fighting bot networks, fighting fraud, get rid of phishing sites, do all these sorts of things that are good for the world, and we can start coming up with ways that we would monitor the bad guys' traffic, just like, you know, there are going to be people who might be bad guys monitoring ours. And we haven't thought about this at all. So I'll toss that open as what can we start doing to use this technique ourselves? Anybody?
Yeah.
I've seen some work in intrusion detection systems, things that capture all the packets going across your network, where they're trying to do some sort of protocol analysis, not on like the headers and the contents, but simply on, okay, who speaks what protocols to whom. So if you see a box suddenly spawning 10,000 new connections and it's never talked to any of these machines before, that might be something that you want to alert on. And there are several IDS systems in the field that do that sort of thing, that, you know, okay, maybe this box has been infected by a worm and is now scanning everyone. And it can be helpful to divine particular new network events that are anomalous against the background. There's a number of bad implementations of this sort of thing, but they are improving. They're certainly better than they were 3 or 4 years ago. And for a good network administrator, it can be very useful to see, you know, the pattern of connections as your boxes get infected.
Also, I'm not entirely certain it qualifies as traffic analysis, except I think it does under your definition. Authorship analysis is fun and easy, and everyone should try it. I think that a generalization of it to program authorship is probably doable and would make, it would be interesting for linking authors of malware. Throwing that out.
Yeah. Informally, things like that do happen. You notice that, you know, this one dude in Russia always leaves one space after a period in his comments or what have you, and you can get an idea of, okay, the style of this is done similarly.
Yeah, and the formal techniques that work are even harder to obscure because you can't, you know, you can try to fool random people by, well, I'll type and I'll always misspell some word, or I'll punctuate like this, or line wrap like this. But the techniques that you want to use for automated machine-based stuff tend to be relative distribution of function words like and, if, of, but, for, the, which, that. And, you know, I know which words I spell right and which words I need to look up, but I have no idea about how my relative frequency of using the and for compares to Raven's. Should we take questions?
Yeah, I'll take a question there.
It's for like tracking botnets and that sort of thing. There's a paper I read recently out of, I think, Portland, that doing just that, looking at hosts on their the campus residential network, and looking at, all right, you know, how many packets do they send to an IRC channel versus, you know, how many they're getting back, and how many different clients are joining channels, and basically detecting botnet command and control planes via that. So it's definitely happening. I don't know how much is actually in production, but certainly in academia they're looking at it.
Mm-hmm. Yeah, that's a very good point. I'll bet that you can also, based upon the other research, you can do things like detect somebody who's running IRC botnet on a non-standard port as well, because you could separate the flow out and say this resembles an IRC flow as opposed to something else, and I don't care what port it was on.
Actually, I was also going to amend that. I know, again, this is academic. They have a working version. There's one system. There's two systems that do roughly similar work. One's called Early Bird, and it's not traffic analysis per se, but it just looks at the simple spread of where things are sent from to in header information, and it's used for automatic worm detection of novel worms. So it looks for small kernels of invariant packets and a sudden widespread distribution to try and indicate novel patterns in worms. So without trying to use signature-based detection. So there's similar systems for that. It may not be true traffic analysis because it's not just raw traffic through a point, but it's the idea of doing basically target address spread analysis in this case. So if suddenly one sender is sending a packet with a small invariant with a small but invariant chunk of information that's not header information, that's not your expected invariant, to a large number of targets at a certain interval or whatnot, it starts triggering it. So there is some similar work. I believe there's one called Early Bird. I can't recall the name of the other one, but so there is some interesting work in worm detection as well that way.
Yeah, I think that counts as traffic analysis. One of the very early things, like a lot of the technologies that we use, they come originally out of military uses. And in World War II, one of the things that they would do is that they could do signal analysis of relatively quick rudimentary form and to tell how many planes were flying to a certain place. So you could get roughly a signature of this cloud of airplanes based upon the radios that they would use to talk back and forth, that even if they were masking it, you could frequently tell, aha, this is the same radio as that other radio. Yes?
So one obstacle to latency-based defenses to traffic analysis is that users really hate latency. And I'm particularly concerned about this for voice applications, where it almost seems like a lost cause because people are so sensitive to latency in voice applications. But I'm wondering, as a general matter, what do we know today about the trade-offs between particular latency padding strategies and the amount of traffic analysis resistance that you get? Is there anything that's clear? People have the sense that there is a trade-off.
So I've looked at this a whole lot. I've worked on two major anonymity systems, Tor and Mixminion, and I've tried to stay pretty current with the literature. Basically, if you have a system, so if you hold the volume of traffic constant, that is, we assume that there's end users sending M bytes total through the system with some relatively constant pattern or consistent pattern between the two cases. A system that has higher variability, it's possible to achieve stronger resistance to traffic analysis at the expense of higher variance in latency. So a system like Mixminion or Mixmaster or something like that can basically, by obscuring the connection between message arrival time and message sending time, keep you from doing timing correlation. Whereas a system that tries to be low latency, not indefinitely, but for a matter of thousands or perhaps hundreds of thousands of rounds at the expense of delaying traffic by the order of 30 minutes to several hours. Whereas if you want to be useful for web browsing, say, much less voice, you need to be fast enough so that most traffic analysis techniques we know will succeed in probably under a minute. Usually probably several seconds of traffic is enough. This, of course, I'm not saying everyone go out and implement high latency systems, though, because when I said in the beginning of this, holding the amount of traffic constant and the number of users constant, well, that's a dirty lie. Most of you would rather browse the web and get an answer back now than click on a page and click on a whole bunch of other pages because the first one you clicked on will arrive at a random time between half an hour from now and tomorrow. You may as well just transport the pages by FedEx. And this is why right now Tor has order 200,000 users and Mixminion has, as near as I can tell, order several hundred users. So, and it's not just a matter of popularity. The lack of popularity hurts the anonymity of an anonymity network because if you get a message from Mixminion, you can't tell which of several hundred Mixminion users sent it. But, and you need to be very clever indeed and have a whole lot of traffic to tell which of your several hundred suspects it is. But, okay, if the message is in Chinese, probably most of them don't speak Chinese. That's, cuts it down. If the message is about a particular city, well, most of them probably don't live in that city. That narrows it down further. So, really, the anonymity set, which is the technical term for the number of people, the set of people who might have sent a particular message or done something, gets very small indeed when you start with a small number. So basically what we know is that you can resist traffic analysis for a while with lots of latency. We don't know a good practical way that you can deploy on the real internet that resists traffic analysis for a long time with little latency. And nobody seems to want to use high latency systems in real life. Although people keep telling me I might be wrong about that, so I might be wrong about that. Order 200,000, although it's kind of hard to tell, they're anonymous.
Could I make a comment on that too? The operational definition that we use that our group uses for low latency anonymity networks is as long as the latency that is added to packets does not mop with TCP, right? As long as it doesn't break TCP, for us it's a low latency communication. And using that operational definition, the larger the delay that you add, the worse is the anonymity that you get at the end.
Yeah. Although to be fair, no currently deployed anonymity system actually transports raw IP frames.
Right.
So nobody is actually doing TCP over Tor or TCP over really any of these. I think, I couldn't tell you about Zero Knowledge. I suspect that they did something clever to try to work around this, but you know, but their product, the Freedom Network, is no longer with us, so it's not necessarily relevant.
Anything else?
Well, I mean, actually, sorry, I just got interrupted, and I wanted to say that the protocols that are used, of course, in anonymity networks are not totally naive, right? I mean, that you don't want to use a tight loop, high timing footprint feedback control mechanism like TCP, when all you want to do is you want to hide your footprint. The other point that may be related to the question that you're asking is, and that's a bit of pet peeve that I have in general with this whole area of traffic analysis, is that we are really not, we really should focus on finding metrics that allow us to think in a structured fashion about how much protection do we get, right? In anonymity systems, they are relatively well-defined systems, right? You have an anonymity set. You would like to hide the anonymity of users. So, you know, so how much information do you leak and all these kind of things, right? So there it's relative, but still it is, I always compare it to encryption. Encryption is so pretty, the story is so simple that you can tell, right? You can tell a customer, you can say, you know what, there is some complexity analysis that tells me that the effort that an attacker has to make to do a particular type of attack is bounded, right, by some whatever. And that does not exist yet in the traffic analysis. We don't even know how to think about it, right, at this point. So if the moment we could come up with some metrics that will allow us to tell a simple story, right, then we would already be in a much better shape. Right.
All right, I'll take the next question.
A minute ago, you were talking about RF fingerprinting, and certainly after the Johnny Cash talk, RF fingerprinting seems pretty powerful form of traffic analysis, and one that just keeps getting easier and easier. I know that several people have been playing with GNU radio and trying to look at cell phone RF fingerprinting based on cheap hardware. And we also know that OS stack client fingerprinting is very easy with passive observation. And in theory, it should be pretty easy to do geolocation via fingerprinting, just, I mean, this much delay. Is there anything public that you know of that is working on actual client IP and TCP-based fingerprinting based on timing and things like that? Because it seems to me like this is tractable.
Do you know?
I mean, I'm not personally not aware. I mean, we do it kind of as a hobby, do a lot of that, but I don't know if any published work.
How plausible do you think that is, actually being able to look at this stream and start working out this person is probably in the San Jose area and working down from that? This is the same one I saw last week.
I would be surprised if it didn't work.
Yeah, I would expect it to work. And I would expect that there are some effective countermeasures that would work very well, and some that would work well enough, but would still let you know some things. I mean, I'll bet that if, say, I were using a VPN back to San Jose, that you could geolocate the exit IP and conclude that I am not in San Jose and come up with a set of likely locations, but that could be, it could include both Las Vegas and London, based upon knowing there's a fast path here and a slow path there.
Right now, my default assumption about any form of traffic analysis is that it will work. Right now in the research field, if you can publish a paper that says there's two kinds of interesting paper. Here's a form of traffic analysis no one thought of before. Look, it works. The really interesting kind is, here's a countermeasure that works. Because countermeasures are much harder, and mostly they don't work. Do you want to do the next question, or do you want to?
Yeah, I think I'm going to, yeah, I'll take one more, and then I'm going to move on a bit. Yeah.
Okay, there was an interesting comment earlier about early bird. And I'm sure all of you are analyzing data differently. Are there any particular algorithms you're using, like entropy algorithms or LCP algorithms, natural language processing algorithms, that you find are showing a little bit more promise than just pretty much mean mode kind of analysis?
They all work.
But what's anybody, I mean, I'm sure you're all looking at different algorithms. Is anybody playing with anything interesting?
Well, the general structure that we have is that we use entropy-based algorithms because they are so good at filtering out noise and outliers, right? So we have the entropy-based algorithms. Until now, we have always been dealing with the underlying system that we are attacking as a black box. We have not the slightest idea what those guys do, right? So we have not the slightest idea what the countermeasure is. We just count packets. So the moment when you start having an idea about what the countermeasure could be, then you bring in hidden Markov chain models, right? I mean, when you don't know too much, you just know a little bit, right? Then you bring in hidden Markov chain models.
Are you using tuples with those? Are you using like an n-tuple algorithm with your Markovs, or is it pure Markov?
The whole variety. We just and with these. We have just been in the last year. We've just been playing with these blind source schemes where we just use minimization of mutual information, all kind of pretty standard techniques that are extremely powerful. I mean, scary.
So we have a really interesting problem that actually nobody knows a whole lot about. We have an interesting problem where there are some extraordinarily effective things that people can do. And this is a group of hackers. So one thing that I'd like to suggest is that people who are out there, you and people you talk to, start thinking about how you might construct systems that use traffic analysis to get some interesting real-world results so that we start learning more about this. In a lot of research, there are a bunch of difficulties because you would need to have informed consent and so on and so forth. And it would be difficult to construct an experiment because you would have to essentially get everybody's permission, say, on a campus network that you could analyze their traffic, and that's not going to work. On the other hand, there are a lot of places like, DEFCON, where it's well known that all sorts of stuff's going on and you're crazed not to expect it. So what might those of us who go to events like this where there is an implicit informed consent that people are doing weird stuff, what could you start doing? And I'm going to toss that out for some suggestions among us.
Well, I'm going to make a hopefully mildly controversial proposal and claim. The wall of sheep is totally 1995. Anybody who isn't using encryption by now is either unable to be educated, simply doesn't care, or is using someone else's user account and password just as a ha-ha gotcha to put them up on the board. Encryption is like pants. If you're not wearing them, you probably know it. This is 2006. On the other hand, I bet, very few people in this room are taking active steps for what traffic they send that is unencrypted to really think about linkability issues and profiling issues in all of their traffic. I bet comparatively few of us are thinking about, well, if someone were looking at the timing of the SSL frames arriving to me, I bet they could tell pretty well what I was looking at on Amazon, what I was doing on eBay, and something like that. Think of how neat it would be to actually have a display or some sort of readout of what everyone was doing that actually surprised people for once about how well it worked.
One of the things that I've seen in people who are considering this sort of thing is they consider the human behavior modifications. Like people might go, oh, all right, I'm at DEFCON, I'm not going to go to my corporate portal website because that'd be bad. And they may make those decisions, but they aren't considering the underlying automated machine-based things like we've been talking about earlier. And these things are getting mapped. Like I'm sure some of you have also had the experience about 3 or 4 months ago where you suddenly started getting a whole bunch of spam where the subject lines were from people like people who have pretty uncommon names. I know I got a whole bunch of it, and there's no way that it's just randomly generated. So people are out there mapping these networks and relationships and using it for their financial creepy purposes. We need to start looking too.
Yes. Oh, another quick thing. Everyone knows at this point, don't go making ciphers until you've spent a lot of time learning cryptanalysis. You might not want to go out and start designing countermeasures to traffic analysis until you've done some traffic analysis for a while, because if you don't, it's not all that hard to design something that surpasses your own understanding of what you know how to break, but I bet if anybody comes up to me with an unbreakable scheme for traffic analysis resistance in the next month or so, experience suggests it probably won't work. So then again, maybe we'll solve this problem really soon, and I'm wrong about that.
Oh, but I have this badass perfect encryption algorithm that I designed myself, and I have this bridge in Brooklyn.
Does it use chaos and fractals?
Oh my God.
Okay, we got 5 more minutes, so let's make good use of it. I'll take the next question.
I have 2 kinds of pessimism that have just come to mind that I wanted to inject. One is the idea of the cost of countermeasures, not just in terms of added latency, but in terms of if you want to send cover traffic, then you need to send more data on the network.
Correct. Briefly, no one has a affordable cover scheme that the average web user is able to implement, that a volunteer network can implement, and that actually helps resist any kind of worthwhile traffic analysis. You are right there. This is an active research topic.
And so certainly for people who are running Tor, even if there were a technically feasible way of doing it, people are already feeling lucky just to be able to dedicate as much network capacity as they do, even without injecting more network capacity requirements.
Exactly. There's no, as the Tor network is currently structured, it seems very unlikely that people would be willing or able to actually provide bandwidth for cover traffic in any amount that would actually help.
The other thing is, even if your packets are encrypted, the nice graphs that we saw before about flow separation and all those nice results are without looking at unencrypted protocol headers. But the unencrypted protocol headers are actually present. So people can actually intercept them and actually use that data as another input. Mm-hmm. So even on top of what we've seen, a real attacker who wants more data inputs would also be able to use source and destination IP addresses, yep, maybe TCP ports, things like that. Well, there's even more data available mm-hmm, when you want to go beyond just counting packets. So it's scary to see what you can do without needing that data.
Yes. Ricardo was telling me yesterday, too, about a system that they had built, which was an IPsec system that did constant load in it. And after they built it, they started using these timing techniques and could then start extracting information from it. And all of that constant traffic running everything full bore was for naught.
So I'd like to make a suggestion for productive work in the future. One of the themes that's gone on here over the last 3 days has been the threat posed to you and me and everyone else from organized crime, identity theft, spam, phishing, and so on across the net. Vixie, and I don't know if he's in the room here, makes a fairly interesting argument that technological countermeasures to botnet command and control centers and so on, in terms of shutting them down and making them more difficult to deploy, will only sort of do what the same sort of things to spammers did, which is create better botnets and better phishers and better identity thefts. And that potentially the more productive approach, the more productive long-term approach, is to sit back, listen to them, find out where they are, and send the fuckers to jail. If you want to participate in something like that, it strikes me that an extraordinarily productive white hat sort of measure in using traffic analysis and signals intelligence is to start listening to these fuckers and find out where they are.
Next.
Hello. A couple of avenues that came up in my mind while we were discussing all this today that came out of just some high-level things that you touched upon. You hit upon, well, briefly, baselining and the idea of baselining, and it sounds like what we need to do is come up with some new techniques of baselining what's going on. I think it is possible to baseline encrypted protocols and then do comparative analysis to figure out more interesting things about what's changing in the baseline from day to day, minute to minute, second to second, session to session, what have you. We probably need to be doing some kind of paradigm shift for baselining. I don't know what that is. The second thing, too, is another avenue that I thought about. Raven mentioned how there's a little bit of apathy when it comes to people's ideas about traffic analysis or their lack of awareness of traffic analysis. Somehow, traffic analysis needs to be made sexy, damn cool.
We're trying.
Yeah.
Go do some and frighten people with it.
Yeah, yeah.
And also, there is a huge opportunity here because we're still at the stage where we don't know what we don't know.
Right.
Yeah.
That we are reaching into the dark and coming up with continual surprises of, oh my God, this is incredibly useful, more than I ever thought. So what we need to do is to start figuring out what's going on, and that means that if you want to do something, the chance that you'll find something useful is really high.
Yeah.
From a public perception point of view, we're in the 1980s and your manager doesn't yet know that you can look at Ethernet traffic that isn't your Ethernet traffic.
You can read my email?
You mean it's not secure because it's on computers?
Right.
It goes to other people?
So,
bizarre.
And something that else was just a crazy idea that bobbed up. You were talking about entropy-based methods of countering. Maybe there's something we can do with the apathy and kind of come up with apathy-based methods of countering. just a wacky idea.
Well, I think that it's not all apathy. I think there's some lack of awareness and some sort of feeling of helplessness. And so, you know, by advancing research in the field, we'll help deal with both of those.
Real quick, because I know we don't have much time left.
Yeah, this is probably our last one.
Yeah, the perception of information that we have for our digital fingerprint, like Greg Conti's talk on the information being collected by Google, Yahoo, so on and so forth, will it help if we reduce our digital fingerprint to make it more difficult to do traffic analysis to associate people's activities down to a single person?
Reduce or lie. One of the things that came up over dinner last night was the existence of those frequent shopper cards that you get at grocery stores. And one of the best things that I've seen for that, I know there are people who swap their cards around and then you just end up with someone else's fingerprint associated with your name effectively. But there's this fantastic guy out in California who has this clone army of people. And if you send him an email, he will send you a printout of his barcode on a sticker and you just slap it on your card. So, you know, there's 10 zillion of him feeding that fingerprint. And that's pretty awesome. I'm sure that if you really dug into it, you could start separating out data flows within the Rob Cocker frequent Safeway shopper, but I don't think Safeway is quite that sophisticated.
Yeah, rising above the baseline of sheer doing nothing helps. Though keep in mind, if anyone really cares, simply lying without pattern is not going to help necessarily. For relationship stuff, if I can link like Raven to some aliases of Raven's because of one thing she did once, well, it's linked no matter what she does in the future.
Yeah.
All right. Thank you very much. Thank you for coming.